graphing linear equations, again, just when you graph ordered pairs or when you graph an equation, because it's the same relationship, right? It's the same relationship. It's just shown in two different ways. I highly recommend using 3 points to confirm the pattern. Okay, because 2 points, yeah, you can make a line. But a third point will confirm that the pattern is correct, meaning that you did your math correct with the equation. So what is the solution? Just like we talked about, well, a solution is a value of a variable that would make an equation true. But in these equations now, we're looking at two variables, right? Which is why we have two axes, an x and a y axis. And we can see, depending on the direction and shape of the line, then we get to make a determination of the relationship between two quantities. Like, for example, let's look at a graph like this one, x and y, right? Now, in real life, these would be labeled. So this would be like hours, say, and y could be money. Right, like we would expect as we work more to get paid more, and then the line looks something like this. Now, be careful, you guys, because this gets more into statistics maybe than you want it to, but it has to do a lot with how graphs are made. All right, so, and then this really doesn't have anything to do with the lesson other than that we need you guys to know graphs, because when you see graphs, particularly on news or mainstream media stuff, you need to know when you're being manipulated, because it's very easy to manipulate people with graphs. And it has a lot to do with the scale of the graph, meaning the numbering on the number lines, and even sometimes what they're labeled at. Let me give you an example. I went to a conference for teachers one time, and they showed some statistics, and it doesn't really matter what the statistics were. So it was just two variables like this, and they said, look at this graph. Look at how it goes downwards like this, right? But when I looked at the graphs, they didn't label anything on the graphs. And to me, that's a huge red flag. Not that you see a lot of graphs that aren't labeled, but when an organization's like, we're the authority on this specific thing, and they're not labeling graphs, I pretty much don't listen to anything else they say, because if you can't even be truthful about what your axes are representing, then, I mean, how can you trust them at all from there on out? So make sure you always pay attention to graphs, because it is mathematical, and that's one problem that we run into is, well, once it's mathematical, then it has to be correct. Well, not always, okay? So graphs and solutions, equations with two variables can be represented by a line on a graph. The line represents all ordered pairs that make the equation true. Again, just like we've seen, if the equation was y equals, I think we did 2x plus 1, right? In 7.2. So we got our x and y axis. This graph would look, I don't know, something like this, right? Which means that the green line represents all ordered pairs that would make this equation true. So if I just put a point anywhere, like there, bam, that ordered pair would make the equation true. If I went down here into quadrant 3, that purple point would make this equation true. It needs to make the equation true. Any point not on the line would make this equation false. So if I looked at this point, let's look up here at that red one in quadrant 2. Whatever the ordered pair is, if I plug the x and y value into this equation, it's going to make the equation a false statement. All right, and any other of these points as well, these red points, is going to make that equation false. So only the points on that green line would make the equation true. Now that's pretty specific, but again, it creates a relationship which then can allow us to make some conclusions about how the two variables are related. So on this one, five solutions to the equation Plot the points and graph the equation y equals 0.5x minus 1. Now, in this table right here, and we need to remember that these are ordered pairs horizontally, right? So negative 2, y, whatever the y value is here, is an ordered pair, which then we can put on the graph. And it would make the equation true. So we got 5 of them. They've given us x values here. Now remember, like we talked about in the last section, eventually they're not going to give us any of these values. They may give us a table. They may not give us a table. It shouldn't matter, because as long as you choose one of the two values, you should be able to solve for the other one. Now on this one, it's nice because they gave us all x values, and the way this particular equation sets up, it's easier to solve when we do have the x values. All right, so let's look at the equation. We got y equals 0.5x minus 1. Now, to start this off, it gives us an x value of negative 2. So I replace x with negative 2, and then I solve this equation. And now you could plug this into the calculator if you need to. We'll just evaluate this. 0.5 times negative 2, that's negative 1, minus 1. Again, this is y, so y equals negative 1 minus 1 is negative 2. So when x is negative 2, y also is negative 2. And I can put this point on the graph now. Now, it doesn't matter the order, you guys. Some students prefer to fill in the table and then put the points on the graph. In this case, I just made the point, so I'm going to put on the graph just so we know which point corresponds with which ordered pair, because I don't have enough colors to color coordinate that. So negative 2 for x, negative 2 for y is going to put this point right there. Okay, so that's our first one. Now I go back to the equation, and if I can erase this stuff, I should be able to evaluate this, and the process is the same, right? And again, if you use a calculator, you could just actually go into it and just delete the old value and replace the new one. You'll see the pattern here. The next ordered pair is where x is negative 1. So I replace x with negative 1. Solving this, 0.5 times negative 1 is negative 0.5. And then minus 1 is going to make that negative 1.5. So I got negative 1, negative 1.5 as an ordered pair. So negative 1, negative 1.5, it's about right there. And again, we see a relationship happening between that red and purple point. But let's continue this. Again, I'll erase some of this stuff here. So next up, x is 0. So I replace the x with 0. And I solve this equation. 0.5 times 0 is, well, 0. 0 minus 1 is negative 1. So 0, negative 1 would be the next ordered pair, which goes right there. And again, I see consistency between the red, purple, and yellow, or orange right there, and it's creating that straight line. And again, a third point is enough to confirm the pattern, but it did want 5 solutions, so let's continue this. So the next value is x is 1. And so 0.5 times 1, that's 0.5. Minus 1, give me negative 0.5. So 1 negative 0.5 would give us this point right there. Now, I do have to approximate with the decimals, but you shouldn't have to do that on the computers, all right? All right, next up, we got x is 2. So x is 2. 0.5 times 2, it's going to be 1. 1 minus 1 is 0. So that gives us the ordered pair 2, 0. So x is 2, y is 0. Bam. And again, it should be in that pattern, which is going to show a straight line. So we can put that on now. Let's see if I can find a good one here. Yeah, something like this. Okay. Now just remember on the homework, you'll only need to put two of the points on the graph to make it a straight line. All right, so here's a problem, right? Graph the equation y equals negative 4x. Well, y equals negative 4x, that seems pretty basic. I don't know, maybe we don't have enough experience to know that it is yet. But we see something different on this problem compared to the last problem that we just did, is it's missing the table, right? In fact, you don't really need to use the table. You can, and most students prefer to. So this is just an old-fashioned t-table, you guys. You don't have to box it in. And I'm only going to do 3 values, okay? Because, again, I want 2 values to make a line and a third value to confirm the pattern. Now, this, even though I've made a t-table, I don't have values of x and y to work with, which means I need to make some up. All right, and this is where be creative if you want, but I would choose values that are very easy to work with. For example, if I said that x were 0, that's a pretty easy number to work with, no matter what the operation is in the problem. Okay, so let's look at that. I got y equals negative 4x. But now I'm looking for what the value of y when x is 0. Well, that's pretty good. Again, I know anything times anything times 0 is 0. So when x is 0, y also is 0, which creates this ordered pair at 0, 0. That's right at the origin. So 0 is always a good number to choose because it's so easy to operate with. But what's another value that's very easy to operate with? I like 1. Okay. 1 is very easy to operate with, not only for multiplication, but also for division, subtraction, and addition. So I go back to my equation right here that I was working with, and I replace x with 1. Well, negative 4 times 1 is negative 4. So I get this ordered pair, 1, negative 4. And so I see x is 1 and y is negative 4. That's going to put me down here. Now that would be fine. That would be fine to graph a straight line. But we're prone to make mistakes even if we're typing it into the calculator. So I want a third point, even though they may not have required it. So I say, well, what's another value that's pretty easy to work with? 1 is easy, 0 is easy, but I don't want to repeat any of these values, otherwise I get the same points. So you could say something like 2 if you wanted to, all right? Well, going back, we can solve this equation when x is 2. So now I got negative 4 times 2, which is negative 8. So negative 4 times, the ordered pair rather, 2, negative 8. And this one will fit on the graph. Now, if it didn't fit on the graph, it wouldn't matter because I had 2 points, but the third point should confirm the pattern, right? This one is big enough to fit this ordered pair, though. So 2 for x, negative 8 for y puts us right there. And again, we see that this pattern is confirmed. Now, I'm doing this by hand, you guys, and that's pretty good, especially when they give us the grid lines like they did. But sometimes when you do it by hand, what will happen is you're going to draw this line like this. Now, when it's on a computer, you can't miss the points, okay, because it's done. But when you're doing it by hand, you got to be careful because sometimes we miss the points like this. Now, when you make an error like this one, remember that all the points on the line should make the equation true. But right now, I got points on this line that look like it would make the equation false. So if you ever make this mistake, you need to be very thorough with how you correct it. And the way you do that is you just make this point bigger, okay? So now it's touching that line, and now I know that it's on that line right there. So this line is the representation of the equation y equals negative 4x. Now, as you do more of these, specifically in this format, y equals negative 4x kind of stuff, you'll see a relationship between this number and the direction of the line. But you'll look at that relationship more in 980. All right, so we know about choosing our own values, and we're going to have to do it on this one too. Graph the equation 2x plus y equals 1. But you guys take a moment and just see if you can graph this equation, all right? We'll give you guys a minute, minute and a half, something like that. Try this one out. See if you can graph it and graph it accurately. Again, try to use 3 points just to confirm the pattern, okay? Give you guys a minute, minute and a half to do that. Go. So I got my t-table ready. Not that you have to use a table, but it's a good way to organize the ordered pairs or the coordinate pairs. And I got the kind of the foundation of my equation set up right here. So it's 2x plus y equals 1. Now again, we got to choose our own values in the table. And again, a good value to choose is 0. So I'm going to choose 0 for x and see what I come up with. So right here I got 0 for x, which will then allow me to solve for y. And again, the nice thing about this is 2 times 0, that, well, just becomes 0. So 0 plus y equals 1. I'll just get rid of that 0 plus, and I see y is 1. So x is 0, y is 1, which would give us a point right here on the graph. Again, it's 0 on the x-axis, 1 on the y-axis. They didn't label these, they probably should have. But this is our x-axis, and that's our y-axis, just so we remember. Now I chose 0 for x. In this specific type of equation, and it is a type of equation, I chose 0 for x, but I could, in this scenario, say, look, I'm going to choose 0 for y and see what happens. I don't know if it's going to be good or bad, but again, hopefully it'll help us to confirm this pattern. So I'm going to go back to the equation here, and let's go ahead and solve some of this stuff. Oh, in fact, should have erased my y, shouldn't I? There we go. All right, well, the x, it's actually just back to x, but y now is 0. Well, since I have 2x plus 0, that's just a phantom 0, you guys. And I end up with 2x equals 1. And to solve this, I divide. So, to answer that question, the reason I'm going with y in this case is because in this equation, the y and x are on the same side of the equal sign. So even though I chose x is 0, I could also choose values of y. It depends on what you prefer. So if you're like, look, I don't want to choose y values, you don't have to. You could say, I'm only going to choose x values, just like we did in that last table. Now in that last equation, yeah, and we'll go over that criteria here in a second. Let's finish this one first so we can see it. And you'll see kind of a problem with this one. Like I chose y is 0, and then what I end up with is x equals 1/2, right? Now, you'll remember on the homework sometimes graphing a fraction like this can be a little difficult. Let's go and put this one on though. X is 1/2, y is 0, so that's this point right here. Now just so not that we have to memorize this right now, but this first one, this is called the Y-intercept. And the reason it is called that is because it's where the line intercepts the y-axis. Y-intercept, okay? And all y-intercepts is where the x is 0. So for x-intercepts, it's where the y's are 0. So this one is also called the x-intercept. And the reason I'm pointing this out is because using intercepts, using intercepts is a very common method for graphing equations, especially when they're in this format, x plus y equals something. And it doesn't really matter if the coefficients are there, but 2 points is all we really need for a line. A third point will confirm the pattern though, right? So again, you get to choose whether you want to choose a value of x or y. So like you guys said, you could choose all x values and then find its corresponding y values. You could choose all y values and find corresponding x values. You can alternate like we just barely did. Now in this case, I'm going to choose an x value, and here's why. When I chose a y value, I got a fraction. And the reason that happened is because the coefficient of x is 2. We need to remember that the coefficient of y in this case is 1. So where you have a coefficient of 1, whether it's for the x or y, I would choose a value for the variable that has a coefficient not 1. Which means I'm going to choose a value of x. So if I go into this and I say x is, again, a nice value to choose would be like 1. Then I go back to my equation down here. Let's fix that up. So I chose x is 1, and now we're solving for y. Well, 2 times 1 is 2. 2 plus y equals 1, so subtract 2 from both sides. And we get y equals -1. Now, by choosing x value in this case, because x had a non-1 coefficient, it gave us a whole value answer at 1, -1, which shows 1, -1 right there. And again, I can see, even though that's kind of close together, that the pattern is confirmed. See, I missed that point again. All right. And there's the graph where 2x plus y equals 1. Now, for formats like this is called standard form. Well, you'll go into more detail in 980, but if you have x and y's on the same side of the equal sign, it doesn't usually matter which one you choose, x's or y's. Except if the coefficients are non-1, like this one, right? Like we would have been better off choosing only x values in this equation because the coefficient of x is not 1. Now, if both coefficients are not 1, you'll learn a strategy in 980 to change the format of this equation into its other format, which is slope-intercept form, which is what we've seen already. Let's look back at like y equals 2x plus 1. We've seen this equation several times. If you see an equation where the y's and x's are on opposite sides, I would choose the variable or choose values of the variable that's being operated on. So where this one is 2 times x, I'm going to choose only x values. If for some reason, not that it usually shows up this way, but if for some reason it was showing operations on y and not x, then I would choose values of y. If it's operating on both, you shouldn't see that too often, but you may. I would look to simplify the equation, and you'll learn about equation manipulation in more detail in 980 also. So just to reiterate, if I have a formula like or an equation like this one, I would choose values for the variable that has a coefficient that is shown. If it's in this format like this one, I would choose values of x only. So for a problem like this one, again, we see coefficients of x and y that are not 1. So maybe it's going to matter, maybe it's not. We just may end up seeing some fractional values on this, okay? So I'm going to set this up, 3x plus 4y equals 8. And again, since I have coefficients of both, well, yeah. Well, you know what? In 980, you're going to learn how to change the format of this equation. But since we haven't learned that yet, let's just stick with the format that we have. If you know how to do that, you're welcome to use it, okay? So in this specific equation, just kind of what I would look at is I see that there's a relationship with 4 and 8. which means if I make the x value 0, it's going to make that 3x go away, right? So right there we got a 0, and it's 4y, and here's what I mean by it goes away. 3 times 0 is 0, which really means that I end up with just 4y equals 8. So that's a one-step equation to solve. I'll divide both sides by 4, and I get y equals 2. So that's this ordered pair 0, 2, which would be this point. So, with the relationship between the coefficient of y and 8, maybe that's thinking too much, I think, about this. Let's just choose another value, okay? And again, you can choose whether it's x's or y's. I'm going to alternate here because we just found the y-intercept. I want to see if the x-intercept will help us by choosing a y value that's 0 also. So I choose y is 0. Let's go back to the equation down here at the bottom. But yeah, now it's 4 times 0 there. And again, the nice thing about that is it cancels out the 4 times 0. So I just have 3x equals 8. And this is where we get a decimal value on this one. By dividing both sides by 3. So x now equals we'll say 2.7. Okay, graphing tenths on a graph like this is going to be kind of difficult. So I got 2.70. So 2.70, again, that's my x-axis, which means it's that purple point which goes through the x-axis. It's on the x-axis. But I want a third point just to confirm the pattern, all right? So, again, you can choose, I don't know. This one's kind of hard to say that there's a right or wrong value to choose. I'm going to go back to the x values. And, I'm going to choose 2 in this case. All right, again, not that you have to, but you can. And let's go ahead and clean up the bottom there. All right, so we have this equation to solve now at the bottom. 3 times 2 plus 4y equals 8. And 3 times 2 is 6. Plus 4y equals 8. We'll have to subtract 6 from both sides. We get 4y equals 2 now. Well, to solve this, I'm going to have to divide both sides of the equation by 2. So let's go and do that. I'm sorry, I said 2. I meant 4. To make that coefficient of y 1. So y now equals, simplified, it's going to be 1/2, you guys. So 1/2, 0.5, and 2, 0.5 would be about right there. Now that's in the pattern, and then we can graph that, right? Just by drawing a line through those points that we have. Now, one of the concerns you may have is none of these were whole values, okay, or integer values. And that's okay. On the graph, we saw that it allows us to graph, in some cases, partial values or fractional or decimal values. So putting these in shouldn't be a problem. Again, even an approximation should work on the homework. All right, so y equals negative 3x plus 2. You guys take a minute and see if you can make the table and graph this equation also. I will give you guys 1 minute. Go. So we're going to make another t-table right here. I just need enough space for 3 values. Then we'll look at the equation. Y equals negative 3x plus 2. But I'm going to leave the x blank so I can put values there. Now remember, on an equation like this one, where it's y equals, if I just replace values of x into this equation, then I'll have the corresponding y value pretty directly, right? I don't have to really use the principles of equality to solve this. I can just evaluate. So I'm only going to choose values of x in this case. And I'm going to choose values that are easy to work with, like 0, 1. And we haven't done negatives in yet, but I would maybe look to try some. So I'm going to try -1 in this case and see what happens. Again, these are values that I chose. You don't have to choose these specific values. Again, instead of -1, maybe some of you chose 2. Maybe some of you guys chose 5. I don't know. We do want these to fit on the graph, though. So let's start with x is 0, right? So I say, well, x is 0 here. Let's go ahead and solve for y. Well, 3 times 0 is 0. So y equals 0 plus 2. Well, y is just 2. And that would give me that ordered pair, 0, 2, which I can put on the graph. X is 0, y is 2. Bam, there it is, that red point. Oh, but let's go back. Okay, and let's now replace the x with 1 and see what we get out of that. -3 times 1 is -3. -3 plus 2 is -1. So, when x is 1, my corresponding y value is -1. So my ordered pair, 1, -1, x is 1, y is -1, bam, right there. So that's 2 points on the graph. Let's go and put our third point on there. Now you see when I'm working with this, I didn't even erase this +2, because I don't really need to, you guys, because I'm not operating with 2 until I evaluate the multiplication as part of the order of operations. So next up, I chose x is -1. Again, you may have chose something else. But again, it's just to confirm the pattern. So -3 times -1, that's +3. 3 plus 2 is 5. So when x is -1, y is 5, which gives me this point right here. And now I'm ready. I can see that the pattern is consistent. It's accurate. And all 3 of these points would make a straight line, so we can draw it. And again, on the homework, the computer would draw that for you. So there you go. Again, when you see an equation in this format, I would only choose values of x in the table and then find the corresponding y values. Now this one's a unique scenario because it just tells us what x is, right? X is 7. Here's what that means in the table. It means that x is 7. And that may sound redundant, but it's accurate. Okay, so when I say x is 7, I mean that x is 7. Well, what does that mean its y value is? Doesn't matter, as long as x is 7. So you could say, well, I'm going to choose 0 for y. Okay, x is 7. And that gives us this point. X is 7, y is 0. Bam, right there, right? On the graph. So the next one, let's say I chose a value of y that is 1. Well, what's its corresponding x value? It has to be 7 because up here, if I put any other value of x into that equation, it would be false. So whatever I get for y, even though it's not shown in the equation, it's okay, as long as the x value is 7. So 7, 1, bam, it goes right there, right? 7 on the horizontal x-axis, 1 on the vertical y-axis. So on the next ordered pair, again, I want 3 just to confirm the pattern. I know x is 7, no matter what I choose for y. So in this case, I'll choose y. Let's say it's -7. I don't know, just to be cute, I guess. But now I got 7, -7. Bam, it's going to put a point right there. Well, is that a straight line? It is. It just looks a little bit different than what we're used to. This one's a straight up and down line. That's better. And it's okay for lines to be straight up and down as long as they're straight lines. So when you see x equals 7, or x equals anything, you're always going to end up with a straight up and down line. It may be right. This one right here is where our orange line is. It could be over here. It could be over here. Never really know until they tell you. But remember that these ordered pairs still make this equation true, right? Like I replace the x with 7. There's nowhere to replace the y, so I don't have to worry about what value I choose for y. Like I said, I just chose these values randomly. You could have said, well, 0, -2, and 8, or whatever values you want to choose. But when you graph them again, you should see a straight up and down line when it's x equals whatever number it is. And that brings us to the next scenario, like you're saying, is we got x. In the last problem, we had x equals. So what is it when it's y equals? Well, this one says y equals -6. Again, the ordered pair needs to make the equation true. Now, it shows y equals -6. So in order to make this equation true, the y value always must be -6. And it doesn't matter how many you choose. You could have other -6's down here if you wanted. But from here, no matter what value of x I choose, it's not going to affect the equality of this equation as long as I choose y is -6. So I could say, well, x is 0, x is -2, or maybe 5, or -3. You just never know. Just choose whatever you want. And then we can graph these, right? 0, -6, bam, right there. -2, -6, right there. 5, -6, right here. And -3, -6, right there. So we can see that this line now is horizontal, like this. Whereas, like you mentioned, where it was x equals, what do we have? X equals 7. That was a straight up and down line. You guys see how these are perpendicular like this? X equals are vertical lines, y equals are horizontal lines. Now again, that's only when it's just equal to a number and not other letters like we've seen before. But this problem and the last one, there's almost always one like one of these two on the final. So I would expect to see one of these two questions types on the final, you guys.